Hi, and thank you for joining me for the week 16 toolkit. Number one. Okay, so we notice that we have an extra plus 90 in here that we haven't had to deal with before. So this is going to have a horizontal shift. Think back to your quadratics when it was inside the parentheses like that. It had a negative horizontal shift. So it's going to shift it 90 degrees in the opposite direction. We have a sine curve. So the parent graph looks like this, but this one's going to be shifted a little bit. So the x-axis will be there. The amplitude we see is for B. Okay, before we go on, we need to factor out the B. Okay, but in this case, we see that the coefficient in front of the theta is 1, so there's nothing to factor. So the period is 360 divided by B, which is 360. The phase shift is 90 degrees in the negative direction. Okay, let's make our table. Okay, so now the beginning is going to be negative 90. Okay, we got that from the phase shift. Now, how do we get the end? We are going to take negative 90 plus the period. So that's negative 90 plus 360 is 270. Now, how are we going to get the middle? We are going to average. So negative 90 plus 270 divided by 2. Okay, so if we were to look at this, negative 90 and 270, do you have a guess as to what the middle is going to be? So let's calculate the average. Negative 90 plus 270 is 180, divided by 2 is 90. So the middle is 90. Okay, so what do you think the average is if I added negative 90 and divided by 2, what would I get? I would get 0. How about 90 and 270? I need the middle. If I were to add those and divide by 2, I would get 180. Okay, so now we need to plug these in to the calculator. Okay, so when we plug in negative 90, we get 0. Now plug in 0 and you get 4. Plug in 90 and you get 0. 180, negative 4, and 270, you get 0. Okay, so let's graph our points. So negative 90 is 0, 0 is 4, 90 is 0, 180 is negative 4, and 270 is 0. And that is exactly what one cycle of a sine curve should look like. Okay, number two. So now we have a cosine curve. So the parent graph of a cosine curve looks like this. The amplitude is 3. B is 3. And we need to factor out B. Okay, so the period is 360 divided by 3. which is 120. And what about the phase shift? So here is the phase shift. So the phase shift is going to be 10 in the positive direction. So plus 10 degrees. Little awkward. It was nice when it was a phase shift of 90. Okay, so let's make our table. Okay, so it's shifting 10 in the positive direction. How do we get the end of the cycle? We take the 10 and we add the period, which is 120. So we have 130. How do we find the middle? We average them. So 10 plus 130 divided by 2, which is 140 divided by 2, which is 70. Okay, average 10 plus 70 divided by 2, which is 80 divided by 2, which is 40. Okay, now we see that it's growing by 30. So if we average these two, we get 100, and we could see that it jumps by 30. So we have theta and y, and we need to plug that into our equation. Okay, so carefully plug in theta is 10 into the equation, and we get y is 3. Plug in theta is 40. We get y is 0. Theta is 70, -3. 100, 0, and 130, I can guess, is 3. So at 10, which is really hard to graph, 10 is 3, 40 is 0, 70 is -3, 100 is 0, and 130 is 3. And there is one cycle of our cosine graph. Okay, number 3. We have a sine curve, so we're expecting this, but with a shift. Amplitude is 3. B, let's factor out the B. B is 3, so the period is 360 divided by 3, which is 120. The phase shift is negative 50 degrees. 50 degrees in the negative direction. So if this is 60, then we have -50 somewhere here. So let's make our table. Okay, so we're going to start at -50. Our period is 120. So -50 plus 120 is 70. Okay, to get the middle, we average. So -150 plus 70 divided by 2 is 10. Average these two. -50 plus 10 divided by 2 is -20. And 10 plus 70 divided by 2 is 40. And we can see that it is growing by 30. So that works. Okay, so let's plug negative 50 in for theta. And we get 0. Plug in negative 20 and we get 3. 10, 0, 40, negative 3, and let me guess, 70 is 0. Okay, so negative 50 is 0, negative 20 is 3, 10 is 0, 40 is negative 3, and 70 is 0. So there is one cycle of our sine curve. Okay, number 4. Now we recognize this table that we've used earlier. Let's notice something. So, okay, number 4. We recognize this table that we've used earlier, and that is going to help us solve these equations. Now, could we plug this into a calculator? Absolutely, but this is going to help us understand a little bit better where this is coming from. So, cosine of theta is negative square root 2 over 2. Now, remember that we've learned that x is cosine. Okay, so cosine is this direction, and y is sine. Okay, so cosine of theta is negative square root 2 over 2. Where is cosine square root 2 over 2? That is at 45 degrees. So our reference angle is 45 degrees. Okay, so where are the 45s on our unit circle? Those go up the middle, right? 45-degree angles. Now, if cosine is the x and I want negative square root 2 over 2, can you see that the negative x values are in quadrant 2 and quadrant 3? Okay. And if it's a reference angle of 45 degrees in quadrant 2, then this is going to be 180 minus 45, which is 135. Now, this says restrict it between 0 and 180. If we went all the way to 360, we would find this one as well, which would be 225. But we say that theta is equal to 135. Why is it in quadrant 2? Because that is where cosine is negative. Okay, number 5. Where is cosine equal to 1/2? So we see that cosine is equal to 1/2 at 60 degrees. Okay, and 60 degrees, these are the tall ones. Okay, but since where is cosine equal to 1/2? Positive 1/2. Cosine is the x, and the so since cosine is x and we want this to be positive, we are talking about these two. And we know from right here that we have a reference angle of 60 degrees. Okay. So we are restricting our answers between 0 and 180. So we're not going to do that one. If we went all the way to 360, then we would have to figure out what that angle is in quadrant 4 with a reference angle of 60. But for right now, we can say that theta is 60 degrees. Number 6. Okay, first let's isolate our trig function. So we're going to add 1 to both sides. These are all cosine. I did not mean for that to happen. So 4 cosine theta is equal to -2. Divide by 4. Cosine of theta is equal to -1/2. So where does cosine have 1/2? Do you see that we have a reference angle of 1/2? Sorry, reference angle of 60 degrees. So 60 degrees, those are the tall ones. So where is cosine negative? Okay, cosine is negative in quadrants 2 and 3, but we're still restricting between 0 and 180. So I need to figure out what this angle is in quadrant 2 with a reference angle of 60. So we could either take 90 and add 30, or we could take 180 and subtract 60. So 180 minus 60 is 120. So theta is equal to 120 degrees. Now, it's important to understand where all this comes from, because when you go on to your next class, you'll be doing this with radians. But right now, we're just getting our feet wet with degrees. With degrees, could you just plug this into the calculator and use inverse cosine? Absolutely. But when you go to radians, you need to understand where this all comes from. Number 7. Okay, since the y is squared and the x is not, we're going to keep the y and substitute out the x. That would be the most efficient way to do this. Okay, so let's solve for x. I'm going to solve for x. I'm going to go ahead and move 2x to that side. So we have y minus 2 is equal to 2x. Divide by 2. So we have x is equal to y over 2 minus 1. Little awkward. We have a fraction. Now let's plug it in. -4 -4y squared plus 122 times y over 2 minus 1 plus 3 times y minus 134 is equal to 0. Distribute -4y squared plus 61y minus 122 plus 3y minus 134 equals 0. Okay, combine like terms. -4y squared plus 64y minus 256 is equal to 0. Now we're going to factor out a -4 equals 0. Okay, so now this is just an easy diamond problem. So I need two numbers that multiply. So we're going to have -16 because of this negative we factored out, and positive 64. So now we need two numbers that multiply to get 64 and add to get negative 16. So that's negative 8 and negative 8. Y minus 8 is equal to 0. So y is a double root and y equals 8. So now we have x is equal to y over 2 minus 1. X is equal to 8 divided by 2 minus 1, which is 4 minus 1, which is 3. So we have x is 3, y is 8. Thanks for joining me.